Stars. Stars are bodies of hot, glowing gas that are born in nebulae. They vary enormously in size, mass, and temperature. Diameters range from about 450 times smaller to over 1000 times bigger than that of the Sun. Masses range from about a 20th to over 50 solar masses, and sulfur temperatures range from about 3000 degrees Celsius to over 50,000 degrees Celsius. The color of a star is determined by its temperature. The hottest stars are blue and the coolest are red. The Sun, with a surface temperature of 5500 degrees Celsius, is between these extremes and appears yellow. The energy emitted by a shining star is usually produced by nuclear fusion in the star's core. The brightness of a star is measured in magnitudes. The brighter the star, the lower its magnitude. There are two types of magnitude: apparent magnitude, which is the brightness seen from Earth, and absolute magnitude, which is the brightness that would be seen from a standard distance of 10 parsecs. 32.6 light years. The light emitted by a star may be split to form a spectrum containing a series of dark lines, absorption lines. The patterns of lines indicate the presence of particular chemical elements, enabling astronomers to deduce the composition of the star's atmosphere. The magnitude and spectral type color of stars may be plotted on a graph called a Hertzsprung-Russell diagram, which shows that stars tend to fall into several well-defined groups. The principal groups are main sequence stars, those which are fusing hydrogen to form helium, giants, supergiants, and white dwarfs. Star magnitudes: apparent magnitude, absolute magnitude, brighter stars, fainter stars. Sirius, apparent magnitude of minus 1.46. Rigel, apparent magnitude of plus 0.12. Objects of magnitude higher than about plus 6.0 cannot be seen by the naked eye. Rigel, absolute magnitude of minus 7.1. Sirius, absolute magnitude of plus 1.4. Star sizes: red giant, diameters between about 15 million and 150 million kilometer. The Sun, main sequence star with a diameter about 1.4 million kilometer. White dwarf, diameters between about 3000 and 50,000 km. Energy emission from the Sun. Nuclear fusion in core produces gamma rays and neutrons. Neutrons travel to Earth directly from Sun's core in about 8 minutes. Lower energy radiation travels to Earth in about 8 minutes. Lower energy radiation, mainly ultraviolet, infrared, and light rays, leaves surface. High energy radiation, gamma rays, loses energy while traveling into surface over 2 million years. Nuclear fusion in main sequence stars like the Sun. Positron, neutron, proton, hydrogen nucleus, neutrino, gamma rays, helium-3 nucleus, helium-4 nucleus, proton. Hertzsprung-Russell diagram. Hotter stars, temperature, cooler stars, more luminous stars. Deneb, blue supergiant. Sirius A, massive main sequence star. Absolute visual magnitude. Sirius B, white dwarf. Less luminous stars. Barnard's star, main sequence red dwarf. The Sun, yellow main sequence dwarf. Arcturus, red giant. Betelgeuse, red supergiant. Stellar spectral absorption lines. Calcium lines, hydrogen gamma line, hydrogen beta line, helium line, sodium lines, hydrogen alpha line, magnesium line. Star of spectral type A. Example, Sirius. Star of spectral type G. Example, the Sun.